Right, so this little video's on sqlite, and sqlite, if I hover over it here on the import module, the sqlite extension module provides a database API compliant interface to the sqlite library. And like, what is sqlite? Sqlite is a light version of SQL. Now, SQL is a big thing, and it does exist. Like when you install an SQL database, it exists somewhere on the PC, but most people don't know where it is. Whereas when we have an SQLite database somewhere here, here's my database there, it's actually one little file, like a .db file that I can open up with a number of different applications. So which is quite nice, and actually installed something. So SQ there we go, sqlite over here. If it pops it up, there's a nice little lightweight application as well, although I can use this lightweight application and sort of like file and kind of like open up one of the files, one of the databases that I've created previously. I'll close that database because I don't need to have this open, but also there's a module or an extension here in Visual Studio Code that lets you use an SQLite database. That's somewhere. It's this module here, this SQLite database, and there's a couple of little tutorials to get you started on that over there. But we can sort of like connect to this database here, so we can sort of like do an open database that way, and you can sort of like see it, and you can kind of like go to go to your your database and like point to files. But again, that's kind of like not the point of it. So at least, but we can see that there's sort of like dummy data. I've put some stuff in here. So that's a couple of different methods. And if I just go to their close database, so we've got it all closed. We're just looking at the coding part of it. So this is SQLite. We've got access to the database in a couple of different ways: a graphical user interface, and also in the actual Visual Studio Code, as we saw. So I was like, okay, this is kind of like relatively easy, and also like go through, and you go through the tutorials online, and this is kind of like the caveat warning, because the tutorials online make it always look very easy, and somebody flies through it and they go, you just have to do this and you just have to do that. And of course, I'm using this in anger as opposed to so when I say in anger, I'm using this for the purpose of actually creating something rather than doing a worked example for someone. So this is kind of like functional in a piece of code that I'm actually trying to do, and I'm trying to capture trade data basically and sort of like store them into a database. And I could use an SQL database, but it's too big for the needs that I have. And an SQLite database is much more adaptable. So, and an SQLite database, by the way, is extremely popular. So I thought, I'll go and have a use of it. So I'm just going to go and hover down on the code, because what started out as being something relatively small ended up being being a class. And although I've done a couple of videos on classes in like Python classes, I tend not to use them. I tend to use functions. Functions are, a little bit easier, and I don't need the indentation and so forth. The purpose of a class, or at least one of the purpose of a class, is its encapsulation. It keeps everything in one place. And there was only kind of like two ways I saw of doing this, because the code is getting so long. One is either to have a new module where everything's kind of like self-contained, and the other version of doing that is if you want to keep it all if you don't want to create a second module, is to put everything into a class. So there were my two options. So I thought, you know what, I have to do one of the two, and I didn't want to create a new module. So I thought, okay, now's the time to create a class. Now, kind of like, how do we do this? So I created this class, Binance, the stats database is what I named the class, and I have to do this connect. So there's a connect method, and once you've done a connection, then you have to create a cursor. I don't really even know the purpose fully of a cursor, all of the various different videos, because it's almost like when you have a connection, you always have a cursor, because the cursor enables you to do executions. And actually, like, this is probably like one of the rare times, not the rare times, but it's kind of like guide towards, and I think I've got it pulled up. Um, don't actually always go through the videos, although I've got videos left, right, and center, but actually go through the code for the first time, because sometimes on the rare occasion, actually the documentation makes life a little bit easier. So here it says import sqlite3, and then create this connection here. And then afterwards it says, in order to execute SQL statements and fetch results from SQL queries, we need to use a database cursor, something that kind of like points to the database and lets you like do things on it. So cursor, because we want to do this cursor.execute. And that's why I'm saying, like, kind of like, you would expect that when a connection's created that the cursor's automatically created, but it's not. So I create one. And if I just go back now, so I've put them into one function because I haven't seen the need, or at least I didn't have the use for or one method. So because it's a function inside of a class, I put it into one method. I could have made it just 2 lines. So this connection and then this cursor, this connection that connects to the database, sqlite.connect, and then this cursor that relies on the connection itself. And then we go down to creating the SQL query. Now, one of the things that we do, again, I kind of modular. I put it into a methodizer. I put it into a method. And the reason why is you only ever create a table effectively once. And in all the tutorials, you see this create of a table. But once you've created the table, and again, like, I actually didn't create the table like this, but I kind of like wrote it out just to have it because it's quite nice because you can see the structure of the table. Once you created the table, you can put this if not exists in. But the reality is I'm not going to keep on trying to like do a create table and check that if not exists every single time. I'm just not going to run this. I'm just going to run this function once and probably never again. Or like in limited cases again somewhere. So it's kind of like I've got this kept and I won't be calling this as far as I know. But anyway, what do? I do this create table if not exists. So it'll make a new table, otherwise it would throw an error and I'd have to handle the error message. And I do handle error messages later on in some of the other bits of the code. And then I go along and create the table using this cursor.execute that we mentioned before. That's always there. And what gets executed is this table here, or all of this query, or this SQL query. That's what it actually is. So the SQL query goes into the execute and the table is then connected. It is then created, and then we have to commit our changes. So again, it's kind of like we create a query, that's one part of it. We execute our query and then we commit it, and that's kind of like it effectively. And then somewhere down below I would have to close a connection, so like when I'm done with it, but I don't close the connection here because I'm intending to close it separately. I might do other operations, and so the reason I don't close a connection is the whole idea or benefit of using a database, so in our case an SQLite database. But if there is a benefit, one of them over using CSV files is that you can open up the database and leave it open, and it gives you a speed advantage because you're not forever opening and closing files. You're just opening it once, you're keeping it open, doing all of your writes and reads and everything else that you want to do, and then closing it at the end of the session. Whereas with a file, you'd have to read it, write to it, and then close it again, and reopen it, read it, write to it, and that would cost you in terms of time if you wanted to do things fast. So that's just a slight lesson in databasing, I guess, in efficiencies. The next bit is insert balance, and this bit I'll be using a lot. I've created a function for this, and basically what I'm doing is I'm inserting data. And the previous video is what I mentioned about putting a dictionary into a pandas data frame. And actually, I haven't done this at this point in time, but I'm going to modify this function if I get time to. What I do here is I just actually take in a dictionary and I pass this dictionary into I guess into an SQL query. Now, Pandas does all of this kind of like for you out of the box. I know it's going to, it makes the user very lazy, but it has a very convenient method where it's got a pd.to CSV if you're writing to a CSV, but to SQL if you are writing to an SQL database, which SQLite is. So it's one line of code. So once your dictionary is created, rather than doing all of this SQL query, I can actually get a pandas data frame and just pass the dictionary in and write it straight to the sqlite database, as opposed to having to do this query. Nonetheless, I followed the tutorials and I did it this way, and it's a bit clunkier, I had errors and had to debug the errors, and I didn't have these double quotes over here wrapping around effectively what was a string over here, and it kept on throwing me error messages, and I had to go on to what actually went into Google Bard loads and loads of times. I wonder if I've got the error messages somewhere up here. A whole bunch of searches I was doing, but basically it threw an error message because this wasn't a string and it wasn't obvious. But anyway, aside from that, it does work. So again, what we have to do is a cursor.execute. Now I've had to put this in a try except block, and we see actually a double except block as well. I had to put it in the try except block. I guess there's other ways around doing this, and again, this is one thing that the pandas data frame would probably handle a little bit better. Which is that basically in this try, if why is it in the try block? Because there's unique data, and I think this value here is, well, in fact this value here is unique and this value here is unique, which means that we can't have the same server time occurring twice. Well, at least I don't want the same server time occurring twice, because it means I've got duplicated data. So I want some of the data to be unique. So it's going to try to execute this insert of data, but where the server time has like duplicated, so I've like tried to write the same piece of data twice, it's going to fail. So here it will succeed and it will say row is added to the database, and here is where it throws the error, which is an integrity error, and it fails. And what I did have outside of that, let's get rid of these tabs that were there. What I did have outside of that was sometimes the database was also locking, and this is what I guess there's advantages and disadvantages to an SQLite database. SQLite, there we go again. One thing that you might notice here is here I've got a read-only version, and here I've got a read and write version. And what I discovered was that if I had this open, that it would lock the database. So I don't want the data, because I've got two applications open for writing, and you can read from many devices from a database, but you can only one application can write to a database at any point in time, and that application's got it locked. And I think that sometimes, and that's actually when I did open up the database here, I could open it, I will open it read only, but if I opened it in this way, I'll make sure that I closed it, so that at least this application doesn't have it open while I'm trying to write from a script that I've got. So the way that you should do it, I guess, is read only for the most part, and then just have one application writing to the database. But anyway, that's a database itself. So that's our application. And if that was open, so if this was open and it was in the writing mode bit, then so if it was open this way round, then now I've got the ability to write to it, then it could throw this type of error there. So and what would actually happen in the code that I've got is it just wouldn't write anything. So I'm just going to go back and make sure I've got the read-only version open there. What would actually happen is if I got this operational error, then it would just say it would just go and close the connection basically, and hopefully at some point in time that that the offending file or the offending application will be closed, and then you'll be able to start writing back to the database without breaking the code. So this is an anti-break of the code effectively, and so is this here. This one here was for finding the duplicated values, and that's where the unique constraint is failed comes out. So and there, if it does come out, it's just like we don't want it to break. We don't want the code to break. We want it to persist. So if this error comes about, I check to see what sort of error it is. If it's a unique constraint error, well, I know I'm expecting that I might have an application open, so that's fine, and I bypass it. So this is all in one little method inside the class. Now, again, and here's the thing, you don't get told about this, but you do your tests, and then you created these dummy or this dead data in a live database because for the purpose of testing, you want to make sure that it works. And then I'm like, okay, fine. I could open up this application here and go along and delete rows from the actual database. But if I'm doing that, then that means I'm opening it in write mode, and I could create my application to crash. So the more optimal way of doing it is through the code, and this is what you don't get shown in coding tutorials. How do you go about and delete items from a database in a convenient way, rather than just kind of like deleting from the application. And the way to do it is delete from and then whatever the table is, and then under some criteria basically. And I kind of like wanted to test this in some way. And again, I have to wrap this into a try except block, and the reason why is because I might try to delete a row that doesn't exist, and it may or may not throw an error. So if it does work, it will be deleted from the database. And if it doesn't work for whatever reason, because the data was never there to be deleted, it will just exit gracefully and close the connection. And then again, one other thing that I needed to have was show data. I should probably comment this. Just show the data from the account balance table. There we go. So all I want to do is show the table, show the data, and this is relatively easy to do. I didn't need to wrap it into a function maybe, but kind of like you do sort of like have to wrap it into a function when it's in a class. I did, or at least it's quite Pythonic to do it that way. But there is we do the same cursor.execute. What we're doing a select star to select everything from our table name, and then this fetch all, so this is an object in itself, and then this part here gets all of the data, and what actually comes back in this fetch all is a list of tuples is what comes back from there. And finally, there's a close connection, and that's for closing it. Now, this is actually like what I call like a helper module. I'll hit save control S. This is like my helper module, which sort of like supports other modules. So we've got this if name equals main guard, and kind of like for the purpose of testing, all the way up the top, we go to if name equals main, and then I've got here this underscore testings in underscore in Python is a placeholder for a private function, because Python does not differentiate between private and public like other languages. So by convention, an underscore means private. But interestingly enough, the linter, if I comment this out, does recognize the underscore here as a function that's not being used. So but anyway, this is now effectively a private module in Python. So this is kind of like my test things, and this is where I instantiate the class, and that was the database that was in here. So it was this database over there. If I just do it was that database over there. This one here, Binance underscore stats.db. So it was pointing to that database, and I created some dummy data. And this is the thing, I create some dummy data and I push it into a database, but it's a database that I'm going to use, but I'm kind of like testing it. So I do my insert dummy data, and then I have to like do the delete balance thing, and I have to make sure that the delete balance actually deletes the dummy data as well. So it's got to have sort of like the right query in there. And then kind of like a show data, and I think I can run this possibly if I do clear, just to make everything clear. I believe that clears everything. And then if I run this, what you would see for sure is you would see the db.show data, I think. So I won't have created any extra data. And actually, funnily enough, I've got this open, and I believe I've got it open in read-only mode. Well, I hope I do, because if I don't, when I run this, it might crash. So let's just... but anyway, I do a close connection, and I actually done close connection twice, because I was just wondering what happens if you do close connection on an already closed database. It's perfectly fine. Closing a connection multiple times is okay. Right, it won't throw an error, so that's what I was like testing for. But anyway, if I hit F5 to run things, let's just have a look and see if anything does get run. Okay. Insert balance. Right. Then these are the types of things that get rather annoying actually. But let's just go on to that over there. So I think this is what comes from the actual dictionary. So if I actually go to total balance, let's just go and find it. So it's not that one, not that one. Right, there we go, dummy data, and it's got to be BTC now, and that's kind of like the issues with it. And I had to select do that for other reasons, because I needed to be consistent with other bits of the code, and this is the kind of stuff that you don't see. So I'm going to hit the stop button on that, and I'm going to try and rerun it again. So F5, get it to see if it works this time. And there we go, we see that a row is added. And the reason that, let me just close that, the reason that the row is added is because on line number 29 here, we've got the inserts. We've got our dummy row that was added. It doesn't say what was added, because otherwise you get really too cumbersome. And then we can see that this line also works. So the row is deleted from the database. So that's quite nice. That was a test working effectively. And this is a bit that I wanted to show, because this is r.db.show show data basically. And if I hover over it, because I commented it, just show the data from the account balance table, and that's what it looks like. And if there's only one row of data in there at the moment, but if there was more rows of data, so this is a list of tuples, and here is my first tuple, and I get one of these every day, so at 1 AM or something like that, or midnight, but I think that's 1 hour out of things because of British summertime. And then finally we close the connection, and again in the closed connection I've kind of like had a little right comment there, so it says closing connections. If I do go to definition, it says here closing the connection, just as something for us to note for ourselves. So that's working with databases, and where I was expecting it to be a tiny bit easier. Well, it might well be easier once you get used to these things. They become easier and easier. Like, which one's easier, writing to an SQLite database or writing to a CSV file? A CSV file you can open up pretty quickly in an Excel sheet, in a CSV reader, in a Google sheet, in a LibreOffice documents. You can open it in multiple different ways. But the database thing, well, I can't open it in multiple different ways, but it's got a speed advantage. So I'm going to try and bear with the database thing. And it's also like, imagine if the data does get long, that if I sort of like want to get the last item, or do some funky stuff, the data, I'll be able to do that directly in the database without having to export a chunk of data to a pandas data frame from a CSV file. So I won't have to read a CSV file into a pandas data frame to do an operation. I might be able to get away with doing quite a hefty operation straight away in the SQLite code. And again, that's just more efficient than kind of like, passing through a bunch of data into anyway. We don't want to be sending chunks of data where we don't have to. So if, for example, I wanted to do a query on the database and kind of like get, I don't know, the last 5 rows of data for some reason, I could read backwards through a CSV file. That's the way that I would attempt to do it. But the conventional way of doing it is to just pass in the whole CSV file into a pandas data frame, and then reading that. So I wouldn't really want to do that. I might want to just do that query, and then from the actual database, the SQLite database itself, and then just pass back the minimal data. Also, like if I wanted to find like the maximum value or the minimum value, and return that, I could pass all of that data. So I could read the whole CSV file into a pandas data frame and then find max very quickly that way. But the passing of the large data might be costly in time, whereas if I can just do that max function straight out of the SQLite database, which I know that I can do that extremely fast and send a much smaller packet of data across the server or whatever I'm doing. So that's kind of like the advantages of using an SQLite database. The advantages come afterwards. So I'm going to try and use SQLite databases a bit more than CSV files, and I guess in my file structure, the other thing that happens is you end up getting a lot of CSV files, and again, they can be useful because you can read them relatively fast. You can sort of like open up a CSV file somewhere. Let's open up one that's let's just let's have a look. Yeah, this one would have open it up, and you can see that there's a CSV file. It's going to start having lots and lots of data. Here we've got 6,500 rows, but imagine that we had a few 100,000 or a few million rows of data. It starts becoming quite clunky. And a CSV file, okay, I could open up in a different application and it'd be a little bit cleaner. But what if I had like many more files? What I had to do in the end was actually make a folder, and the folder to contain all of the CSV files, and they're all kind of like flat files. There's nothing really like it's okay. It's definitely doable, but the database just keeps everything in one file, kind of like neatly. And again, if I wanted to kind of like do something with this data, I for sure would have to read it into a pandas data frame. I'd have to read the CSV file into the pandas data frame, and I'd have to operate it on that way. So I wouldn't really operate on the file directly, although I could do read CSV, and if I wanted to sort of like get, I don't know, the maximum quantity, the maximum trade size or something out of this, I could read the CSV directly. I'm not sure how efficient that would be relative to reading through a database, which would, I think, would have some speed advantages. So that's basically it. I think I might sign off on that. But that's really SQLite, and at least the beginnings of SQLite, like creating a table, um, creating a database, creating a table in the database, and then appending values to the data and deleting, appending values to the table, and then also deleting values from the table. And I will have to, at some point, or the whole point of it finally would be to create some extra functionality where I can extract some useful data from there. So that's it. That's SQLite in Python.